This is a big question that I get a lot. Where does the red lead go? You're gonna use this port 99% of the time. And then this is for resistance. We're gonna go through all these different settings, so don't even worry. Now that we kind of have that baseline of knowledge, we're gonna go through a bunch of examples. We're getting 0.41 amps. That's still twice what the next setting down would be for. So if I move it to the next step down, then I should be able to read this to the hundredths value instead of just the tenths. 0.010, and we're in the 2M setting. What is that? Hey folks, welcome back to the channel. And for those of you that are new, my name is probably Luke. And today we're gonna be going over all of the different test settings on your Kaiweets KM100 2000 count digital multimeter. Now I've been getting a lot of requests in the comment sections of my videos of how to do non-destructive electrical testing. And so it sounds like a lot of you are experiencing, you're getting a meter, you're trying to troubleshoot something, and then you accidentally short something out. And that's really common when you're beginning. We gotta get a better understanding of the foundations of electrical testing and what all the different ports and settings mean so that you can then apply it to your very specific electrical troubleshooting need. And that's what we're here to do today. So Kaiweets is not a sponsor of the channel, but they are an affiliate. They're always sending me discount codes and different kinds of links. So be sure to check out the description down below the video for anything that they currently having going on. With that being said, why don't you grab a snack, have a seat, and let's get into it. The Kaiweets Digital Multimeter 2000 counts. We're gonna get into what 2000 counts means. Model number KM100. Let's open the box. I haven't gotten any complaints yet about the box opening portion of these. If you guys think it's a waste of time, let me know down in the comments. Ooh. Kaiweets always does have good packaging though. Comes in a nice little case. I appreciate that. That just looks pretty slick. Let's see what you get in here. Ooh. A set of batteries. So not USB-C, rechargeable. Set of small leads. And something to always note when you're looking at your meter is whether or not your ports are fused. And this symbol right here is saying that both ports are fused, which is always good. And then your owner's manual. Batteries in here. QC passed, I always like when I see that. Okay, and then I imagine the fuses, if you do blow one, you're gonna have to take those 4 screws off and get down to it. Like most meters, it has a stand, but I won't be using the stand just because it's hard to see the dial and the screen when it's on the stand. So I like to use my little AirPods case to set the meter down onto, and then I try to be mindful of glare. And then it looks like we've got a little bit protective cover on here. Something plastic to try to get that off. Okay, great looking screen. And there's these little dust caps. Come with all meter leads in shipping. We'll just go over where you plug your leads into. For plugging in our meter leads, not every meter is the same, and that's why we want to look very closely to the labeling that they have here. So we have here, this is our common port. This is where our black lead will always plug into, and it will live forever. And you might be thinking, well, if that's where it's supposed to always live, then why do you have to plug it in there? Leads are a wearable part of the multimeter. They do go bad eventually, no matter what leads that you get. And that's why they have these banana jack ports for them, is so over time, you can replace them. And then our red lead. This is a big question that I get a lot. Where does the red lead go? You're gonna use this port 99% of the time. This is for continuity, diode, capacitance, although I don't see a capacitance setting on here, volts, ohms, and milliamps. Only when we're measuring current Okay, because this port's only rated for 200 milliamps. So when we're making an in-series current measurement that's over 200 milliamps, but less than 10 amps, we're going to use this port. For everything for right now, it's going to live in here. When our red lead port lives in here, our testing is considered non-destructive. That means you shouldn't necessarily be able to short anything out in this configuration unless somehow you're shorting out the leads directly during your testing. When we configure the meter like this, now we've converted the meter into a jumper wire that can measure current. There's continuity through these wires all the way through, almost no resistance. So that's what's causing people to short things out. It's a really common mistake, and it can make you have confusing measurements and everything like that. So we want to make sure these leads are fully seated, and we want to pay attention to where our red lead is plugged into, what port. All right, before we start utilizing our 2000 count manual ranging multimeter, let's go over what exactly that means, because that's going to help establish the foundations on which we build of how to do the measurements that we need to do. So the first explanation that I like to go over is, what does manual ranging mean? And that's going to have to do with why there's so many different numbers on here and why it can be a little bit overwhelming and possibly confusing, and that's completely fair. The first thing that we want to know is that our meters and all meters are in the metric system. So we're going to see capital M, capital K, lowercase m, sometimes other units on here. Those are the main players. So when we see a capital M on a meter, that's going to be for mega, or think of millions. So we have a 20M setting on this meter. What does that mean? That means for that setting, we can measure up to the cap 20 million with a capital M. We can measure up to 20 million, and then let's see, there's a little horseshoe symbol on here that stands for ohms, or that's your resistance setting. So we have it sectioned off in a couple different color codes here. So like this V with the squiggly line, that's for measuring AC voltage. V with the solid dash line, that's for DC, this grayed section here. Then back to orange. This is for DC current. This gray here is for continuity and diodes. And then this is for resistance. We're going to go through all these different settings, so don't even worry. So that first setting there means I can measure up to 20 million. Well, the next setting down is 2M, and that stands for up to 2 million. But our 20M setting can measure 2 million as well. And then then it's like, well, then why are there so many different values on here if I can measure 2 million ohms with the 20 million setting? And that goes into counts and resolution. I always like to think of utilizing a manual ranging meter like using a microscope. Whenever I first use a microscope, I always set, the glass way back here, and I set my subject onto the little dish thingy, right? And we can see that there's stuff down here, but it's not very clear. And then as we dial in our microscope, things that we've set in to look at come clear, and they come into detail. And with a lot more detail, we get a lot more accuracy of what we're looking at. And that's kind of the same thing with our manual ranging meter. When we set it to the 20M setting, it's kind of like having a microscope way back here. We can see all this smaller stuff, but it's kind of fuzzy. And then as we dial in the settings, it's kind of like we're zooming in on what we're trying to figure out. And so a good approach that I always like to use is, when I'm using a manual ranging meter, I always start with the biggest number, and then I work my way down. There are practical reasons why we'll start with the biggest number when we get to current measurements, but just as a good rule of thumb, and until you're able to start anticipating your measurements, I like to always start with the biggest number and start to dial things in. Let's kind of touch on counts. What does it mean when they have 2,000 counts written out? 2,000 counts just is letting you know the number size limitations of the meter. Notice how this display is kind of small. Here we go. We've only got a 0.01 on our display. So what's going on here? So 2000 counts really means it can display up to 1,999. It's the biggest number it can produce. It can't say 2,000 across this screen. It can say 1,999 down to 0. There's 2,000 values within that range, right? We have all of these different settings in here to help dial things in, because if I'm trying to show you the value 20 million on a screen that size, how would I do that? Well, you would do it by adjusting the decimal point and using it as a placeholder. Let's take some resistors here. And we're gonna do a lot of examples of all of this to help really drive it home. It just takes a little bit of practice and patience. You'll get it no problem, I promise. And if I don't, yell at me in the comment section and then DM me and we'll go over it together. Okay, right now I'm reading on my screen. That's what I have down here. And in case you can't see, the mega is down here by our little horseshoe value. So I just read 1.04 mega ohms. Well, they're telling me that the way that I should be reading this, you have 1,040,000 ohms present here. Say I want to get a more detailed reading of that. That's a big number, but I think we can get a little bit more information. I have a 2 mega ohm setting down here. 1 million or 1 mega ohms is still smaller than 2 mega ohms. I can put this down to the 2 mega ohm setting, and now I get another digit there. Now it's saying, oh, it's actually 1.042. So that's 2,000 ohms that I was missing in detail from my value. So it's kind of important that we understand our counts and our ranges, and that it's in the metric system and our units and all of that stuff before we kind of measure anything. But now that we kind of have that baseline of knowledge, we're going to go through a bunch of examples to really help drive the point home. And we're going to start with the volts AC setting, and then we're just going to work through it clockwise. And then down in the description, there should be timestamps for whatever you're needing to try to figure out and measure first. We're going to start with volts AC. Our scenario is that we have an outlet here that we would like to measure. Now, I would always recommend using an outlet tester, such as this one, and this will tell you the voltage, and it will tell you the wiring, and it's whether it's in the correct orientation, or terminated correctly, excuse me. But if we just have a meter, we can also measure this outlet. Now, I'm not a big fan of digging probes down into outlets, but if that's all you got, I would wear gloves and safety glasses. I like to start with the biggest setting, so I'm gonna set it to 600 volts AC. Put my probes down in here till I get a measurement. Now, I'm showing 120 on my screen, and I've got 2 more settings worth of range on my meter. I have a 200 volt AC setting and a 20. The measurement that I'm taking right now says 120 volts. It would be nice to get a little bit more accuracy. Since 120 volts is less than my 200 volts AC setting, because remember, whenever we see a number on our meter, we can measure up to that value. So if I can measure up to 200 volts, and this is 120, it's a little bit less than that, can move it down here, decimal place moves, and now we can read it to the tenths value, right? So we're getting a lot more detail. The next setting down is for 20 volts AC. Now this value is way greater than 20 volts AC, so if I move it to 20 volts AC, I'm getting an OL. And that OL is going to stand for out of limits. It's saying whatever you're trying to measure is too big of a number for me to display. And so we can say, okay, we can move it back up. And there we go. And then we have our correct setting. Now, let's say I want to hold this value. I can just press that little H there, and I can take my probes out of here. And then if I need to write that value down or anything, now I have it stored in the meter. And then let's see, if we hold this, then we'll get our backlight. So that's volts AC. So we're gonna go through it again with volts DC. We can do that. It says that it can measure up to 600 volts DC. So with AC measurements, it doesn't matter if the red's on the hot or on the neutral or whichever, because the voltage and current goes back and forth. When we make DC measurements, we wanna be a little bit more mindful of our lead polarity. So red's gonna go to positive and black's gonna be our ground or our common or our negative. So we have a little battery here. It's labeled for me, plus and minus. Now I've got a whole bunch of numbers here. So given what we've just gone through, we can set it to 600 because that's the largest value here, and we kind of always want to start with the largest value because we don't know what it's going to say, right? We're trying to get experience with our meter, and then we can take a measurement. Okay, we get 9. It's a 9-volt battery. That's cool. But as we gain experience, we're going to learn that 9 volts isn't enough information. It's not enough detail to know if this is a good battery or if it's charged. So we'll want to dial in the resolution. The next setting down is 200. Well, we know 9 volts is well under 200 volts, so we can set it there. And now we can read it to the tenths place. Oh, it's actually 9.4 volts. And then it looks like we can go one more time. We've got a 20 setting, 9.50 volts is what we're getting. Now the next setting is 2, and we can expect that it'll say OL because we know that the battery is well above 2 volts. So when you're seeing OL and the decimals moving around, this is what's happening under the hood, so to speak. And then it can measure up to 200 millivolts DC. If you're still learning those units, if you're seeing a 200 millivolt like that, think of it as that. 200 millivolts is really 0.2 volts. Okay, next up is when things get a little bit complicated, but that's okay. Just bear with me, and this should make sense. Next up, we have our current. That's what the A stands for. It's amperage. We're going to measure the amperage of a circuit. A solid and dashed line, meaning that it's only rated to measure DC current. Don't try to measure AC current out of this thing. The first thing that I'm going to do, if I'm going to make a current measurement, I'm going to put it to the biggest setting because I don't know how much current a circuit's going to produce, right? That's why I'm using the multimeter in the first place. I'm going to set it to 10 amps current, and I'm going to move my red lead over to here. I want to be very mindful that now in this configuration, my meter is a jumper wire. And if I just took a jumper wire and I started putting it to different things, I would short something out, right? So we can short things out in this configuration. Luckily, it does have a fuse, but we still want to exercise caution and make sure that we do our measurements carefully. So to measure current, we have to do that in series versus parallel. When we're thinking about making a measurement in parallel, just like how we did with the battery, red to positive, black to negative. Well, if I did that right now, it's a jumper wire, it'd blow the fuse in the meter, and we don't want that. We need to make our measurements in series with the circuit, and we're gonna use our new jumper wire to be the jumper wire of our circuit. So you can see here that I have an incomplete circuit, right? It can't complete the circle, and I want to know the current measurement of it. So I'm going to use my meter leads to complete the circuit, and then I'll get a current value. And I can go ahead and hold this, and then we can talk about it. So I'm measuring 2 amps of DC current. That's what that's trying to tell me. Now, my next setting down for the current measurement is 200 milliamps. This is what I'm currently measuring at, and this is what the next measurement down is available to me. Now, 2 amps is well above 0.2 amps. So if I had it in this setting and I tried to measure that current, there's a chance that I could blow a fuse in my meter. I could short something out. So we know that we can't get any better resolution than what we have in this configuration. And this is why I like to start big and work small, is so I can get a sense of the real value of something and then dial it in appropriately. Let's try a different load. So I have my meter in the same configuration. I've got a load here. I'd like to measure it. We're getting 0.41 amps. That's still twice what the next setting down would be for. But something cool that we can do when measuring current, like a useful thing for it, is loads. You know, the more resistance this motor is going to have, the more current it's going to draw. So what's that useful for? Well, if we know what the motor should be drawing, and we see that its value is way more, that could be an indication of some kind of fault in our motor, okay? Like a bearing's going out or something like that. Or whatever load it's trying to move could be starting to seize up. It's still at 0.42, so we still can't go to the next setting down. So let's bring in some much smaller electrical loads. This backlight has not turned off once, and that is a really cool feature. Okay, still in the same configuration. I'm still, basically have a giant jumper wire here, so I want to be very mindful of the measurements that I'm going to make. And let's measure this. Okay, now we're getting to some small current measurements. This is 30 milliamps of DC current, or think of it as 0.03. So 0.03 is well below our 0.2, so that's telling me, okay, we're making small enough current measurements that we can step down to the up to 200 milliamp DC measurement, and then I can swap this lead back over to here. Now let's take that measurement again and see what it says. What did it say before? Like 0.03? So we're thinking somewhere around 30 milliamps of current. Remember, our values changed. Now we're working in milliamps, so we want to keep that in mind. Okay, so now we have a lot more detail. It's not just 30 milliamps, it's 37.2. It's going up because there's a little bit of current going through our resistor right now. Let's try another small measurement. Okay, 12 milliamps. 12 is smaller than 20. 20 is the next step down. So if I move it to the next step down, then I should be able to read this to the hundredths value instead of just the tenths. And there you go, 12.26. This detail is going to be really handy because we're making such small measurements. Let's go to the next one down. Cool. And then this one is 1.19. 0.11. We've put our leads, remember, whenever you're done doing current measurements, always make sure you put your leads back to this configuration or you're gonna short some stuff out, and that's not fun for anybody. Next up we have continuity and diode. Let's go over diode first. So when measuring a diode, that's what this little symbol is here for. It's a little arrow with the line. I always like to think of the line on the diode in the same orientation as the line on the diode setting. And that kind of helps me remember the flow and the direction. So if we're going to measure this diode, we always measure them in both directions. Okay. And this is what it's measuring in the first direction. This is going to be the amount of voltage drop across our diode. It's saying 0.545 volts, or we can think of that as 545 millivolts. And we always want to see somewhere between 500 and 800 millivolts of voltage drop across our diode in one direction, and then in the other direction we should still see that OL, and that means that we're not getting any backflow in our diode. So this one's testing good. And then we have our continuity setting, which is that little speaker symbol, and that's letting you know whenever you have flow, continuity, that it's going to emit a tone. And then it gives us a little bit of a resistive value there. What is this setting good for? The reason why you have this mirror, or why you're starting to get into this, is you're probably encountering a lot of wires or circuits, and it can be really hard to keep track of who's who and what's what. And so the continuity setting allows us to easily determine what wires have continuity to each other, right? So if we have like a bunch of wires, like say we're dealing with a bunch of wires for a car, and there's a bundle of like 40 wires, and we want to figure out who's who, the continuity setting is great for that. And so it can let us know, like in this scenario here, I'd like to know which wire goes to which terminal. I don't know that. There's no way to look at it and determine that. If I use continuity, well, I can figure out, no, the red wire doesn't go here, but it does go here, okay? And then my black wire does go to this first one, but not here. That's that tone that we're hearing. And then the last round of settings is ohm setting, measure the amount of resistance. Now, resistance setting isn't just for resistors. Keep that in mind. Any kind of electrical load is going to have some resistance to it. Even, this motor is going to have some resistance, even though it's very small, 0.7. So we can use resistive values to help us in troubleshooting circuits. I'm just going to use resistors to help you get comfortable with knowing what range to set it on, but any kind of electrical circuit is going to have some resistance to it. For practice, you all should already know, we're going to start with the biggest value, and then we're going to try to figure out what's going on and what it says. So the first one, it just says zeros, but that actually tells us a lot of information. By saying nothing, it says a lot. If we had OL, that would mean that there's no continuity into the circuit. Something's open. It's an open circuit. But because we're getting all zeros, it's trying to say, hey, there's some level of resistance here, but it's too small for me to be able to read on this setting. Keep going down. Keep dialing it in. We can put it to the 2M. Still nothing. Okay, and now it says 0.3, and we're in the 200K setting. How could we think about what that says? What is 200K? Well, 200K is really 200,000. That's the setting that we have it on. And our meter says 00.3. We can use that decimal to think of the comma in 200,000. So what the meter is actually saying, 00300. It's telling you it's 300 ohms. 300 is way smaller than 200,000. We've got plenty of more dials on here. We can keep working it down, and we're gonna see this 3 scoot over, and then we might see it turn into like, 247 or 289 or whatever as we dial in and get better detail and better resolution to our measurement. Let's take this hold button off. Let's keep working down the dial. We're in the 20K setting. It says 0.32. So what that's information that we're getting now, as it says 0.32, is it's actually 320 ohms of resistance. We're getting more detail. There was 20 ohms in there that was buried in there that we couldn't see. Now we got it to the 2K. Okay, it's saying 0.326. So there was another 6 ohms buried in there. And we get to the last one. Oh well, out of limits. The last one says 200. Our number is 326. We have 326 ohms of resistance with that one. Let's do one more example, just to really drive it home, and hopefully you all should know pretty easily what it's trying to say. Okay, so I'm going to start at the biggest setting, 200 mega. I'm going to put it on a resistor. Okay, we have zeros, so that means that there's some kind of resistance. Let's dial down. Okay, it says 0.010, and we're in the 2M setting. What is that? It's 10,000 ohms. Keep going down. It's actually 9,900. Okay, we're in the 20K ohm setting. We have 9,940 ohms of resistance. There you go. There's your Kaiweets KM100. How to go through it. If you all are learning, I've got a bunch of shorts and different videos on a lot of different electrical concepts. Don't forget to check the description for any links or discount codes that Kaiweets has hooked me up with. And I hope you all enjoyed it. Let me know if you have any questions, comments, or concerns down in the comment section, and I'll check you all in the next one.